In this video, I'm going to show you how to plot the absolute value of any function. So here, for example, we're given this graph of y equals f of x. That's our initial function, that's shown right here, this kind of U-shaped thing. And we want to plot y equals absolute value of this function here. In order to see what effect the absolute value has on the graph, it's handy to take some points on the graph and just run them through the absolute value. So for example, here we've got a point -6, 3, and we'll put that in a table with x and f of x. X is -6, f of x is 3. And now for the function y equals absolute value of f of x, the output is just the absolute value of the original f of x. So output would be absolute value of 3, which stays the same as 3. And we're just going to do this for all of these points, and once we have this table filled out, we'll go ahead and plot these points on the graph to make y is absolute value of f of x. We'll connect them up and we'll look back and see what changed. Okay, so that was the first point here. Now let's take the second point, -4, 0. That's in our table. X is -4, f is 0. And for y equals absolute value of f of x, we want the absolute value of 0, which is still just 0. Okay, so it doesn't seem to have any effect so far, but maybe something will change in this next point. So the next point, -2, -3, x is -2, f is -3, and absolute value of f, absolute value of -3, well, absolute value is just the positive value, so it changes from -3 to +3. Okay, that's significant. Something changed there. Now that's the same idea for the next point. X is 0 and f is still -3, so absolute value of -3 is going to be +3 again. Same idea again for the next point. X is 2, f is -3, so absolute value is +3 again. And now we're back to f is 0 for x is 4, f is 0, absolute value of 0 is just 0. And for x is 6, f is 3, and absolute value of 3 is just 3. Okay, so we've got our points here. Let's go ahead and plot them. So first of all, let's plot -6, 3. So go over 6. There's 3, and then up 3. So here's a point. Let's label that. That's -6, 3. Okay, next point, -4, 0. So go over 4 and up 0. So just right here. That is -4, 0. And then next one is -2, 3. So over 2 this way and then 3 up. Okay, now we're starting to see something different. Originally the point was down here, but now it's up here now. Okay, that's cool. So let's write that in. That's -2, 3. Next point is 0, 3. So 0, 3 is right up here. We'll write that in. 0, 3. And then we've got 2, 3. So 2, 3 right here. Label that. And then 4, 0. So go over 4 and then lies on the x-axis. And the last one is 6, 3. So over 6 and up 3. Oh, let's label this one too. That was 4, 0, and this one was 6, 3. Okay, we've got our points. Now let's go ahead and connect them up with our straight edge here. So just connecting the dots here. Here's a line, and there's another line segment there. And then through these 3 points, and then from this point down to the next point, and then up to the final point here. And there we go. So that is our graph of y equals absolute value of f of x. So looking back, what effect did this absolute value have on the graph? Well, this segment above the x-axis here stayed the same. But then the part that dipped below the x-axis was reflected over the x-axis. Now it's above the x-axis here. And then the part here that was originally above the x-axis just stayed the same. Okay, so absolute value just takes whatever is below the x-axis in the function and reflects it to be above the x-axis. the finding from the previous example does indeed hold for all functions. If we're given a graph of any function, y equals f of x, then the graph of y equals absolute value f of x is constructed this way. It's the same wherever y is positive on the original graph, but it's reflected in the x-axis wherever y is negative in the original graph. So knowing this, let's do another example a little bit more quickly. Say we have this function here, and we want to construct the graph of the absolute value of that function. So let's use this big idea concept to do that without having to go through the process of picking up points and finding their absolute values and then plotting them. So really, we just need to know where is the graph positive here and where is it negative, and we'll deal with those sections accordingly. So the crossover point is where the graph crosses the x-axis. That's where it changes from positive to negative. And that is the point right over here. So everything to the right of this side is positive y values. So it's just going to stay the same because y is positive here, so absolute value is still just going to stay positive. So let's draw that. So there's a point here, and it just goes up with looking like a slope of 1. So a bunch of points here. Let's connect those with our straight edge. Here we go, plotting here, and okay, so there's the positive section. Okay, and now how about what happens to the left of that point? Well, to the left of that point, the y values are negative. So because y is negative, all this graph to the left of the point there gets reflected in the x-axis. So instead of below the x-axis, now it goes above the x-axis. So this point here goes to that point there, this point here goes to that point there, and so on. So that's these points here. And we can connect those with our straight edge also. Line it up and draw. And there we go. So that's our graph of y's absolute value of f of x. Here's another example. It's the same idea. We've got a linear function, f of x is 3x minus 2, and we want to plot the graph of y equals absolute value of f of x. We're going to do this just like before. We'll use the graph of f of x and then just reflect the negative portion to get the graph of absolute value of f of x. But first of all, this time we have to construct the graph of f of x on our own. It's not just given to us. So first step, let's plot this graph of f of x right over here. So we'll just label it here, y equals f of x. Okay, how should we plot this? Well, this is just a line. And a line consists of a y-intercept and a slope. The y-intercept here is -2, so let's put a point there, y-intercept at -2, and then a slope of 3. So that means it goes up 3 units over 1 unit, up 3 units over 1 unit. Rise over run is 3 over 1. So up 3 units over 1 unit right here, up 3 units over 1 unit, and so on, and goes the other way. Also down 3, left 1, and so on. And now we can connect up these points, and let's see. So it goes just like this. Here we go. Okay, cool. So now we've got this graph here, and we see that it crosses the x-axis at this point right over here. So now to graph the absolute value of f of x, we need to address the positive and negative portions of the line accordingly. So let's put that over here. This will be y equals absolute value of f of x, and let's deal with the positive section first because that's the easiest. So it's starting here, and then everything to the right is positive. So that's just going to stay the same because absolute value of positive is just positive. So we'll have the same points that we had originally, here, and then here, and then here, and then we'll just make it run until it hits the x-axis. So connect those points and make it hit. There we go, and then we're stopping at the x-axis because that's when things change because of the absolute value. So what changes? Well, the absolute value just reflects all of these negative y values to their positive y values across the x-axis. So this point here, which was 0, -2, now becomes 0, +2. It becomes over here. And then we've got another point that was -1, -5 goes to -1 and +5 here. And then we're just up 30 over 1, up 30 over 1, and so on. Okay, so then we just connect these, and let's do that. Let's connect these. Here we go. Okay, so then there we go. That's our graph of y equals absolute value of f of x. For our last example, we're going to do something pretty similar to the previous one. We're given a function and we want to plot the absolute value of that function. So again, in order to plot the absolute value, we need to get the graph of the function, and then we need to take the negative parts of that function, the parts with negative y values, and reflect those over the x-axis. But first step here is to plot the function so that we can know what we're dealing with. So how do we plot this function? The linear function was pretty easy, but quadratic function is a little bit more difficult. Well, we're going to have to know where the function crosses the x-axis, because that's like the cutoff between where y is positive and where y is negative. So why don't we find out where it crosses the x-axis first? We'll find the roots of this function, and then we'll draw the graph using that. So roots of that function are where the function value is 0. So 0 equals x squared plus 2x minus 3. So how do we solve this? Well, this is a nice factorable equation here. So why don't we factor it? This is 0 equals x, and what multiplies to -3 and adds to 2? Well, how about just 3 and -1? 3 times -1 makes -3, and then 3 plus -1 makes 2. Great, so we're good. Okay, so that's the factored form, and then the solutions to this equation just come from setting each factor equal to 0. So 0 equals x plus 3, and 0 equals x minus 1. So this one is x equals -3, and this one is x equals +1. Okay, so these are the roots of this parabola. That's where it crosses the x-axis. So let's go ahead and plot those. This corresponds to the point -3, 0, and that corresponds to the point 1, 0. Let's put that on our graph. So -3, 0 is right over here, 3 units to the left, and 1, 0 is right over here, 1 unit to the right. Okay, so the last thing that would be helpful for us to have is the vertex of our parabola. We know our parabola is an upward-facing parabola because positive x squared coefficient, so it looks kind of like this, but why don't we find exactly how deep it curves downward? So the vertex always occurs right in between the two roots. So we can just take the average of the roots, and that'll give us the x-coordinate of our vertex. So what is halfway in between -3 and 1? Well, we can just add -3 plus 1 and divide by 2, take the average, and that comes out to -2 over 2 equals -1. So -1 is the x-coordinate of our vertex, and the y-coordinate is f of -1. F of -1 is just -1 squared plus 2, -1 minus 3. -1 squared is 1, and then plus 2 times -1 is minus 2, and then minus 3. So 1 minus 5, and that makes just -4. Okay, so vertex is -1, x-coordinate is -1, and y-coordinate is -4. Go down here. Here we go. Okay, so there's the vertex, and now we have enough information to draw a pretty nice graph of this parabola. We'll make it start at the vertex, go up to the root here, and then just continue on up. Okay, and then same with the other one. Start at the vertex, go up to the root, and continue on up. Okay, nice. So now we have the graph of y equals f of x, and we want to draw the graph of y equals absolute value of f of x. First of all, let's start with the easy part. So the easy part is that the places on the original graph that have positive y values just stay the same. So where does it have positive y values? Well, coming from the left, once we hit this root, we're coming from positive y values, and then here's where it crosses into negative y values. So let's focus on the positive y values here. This section here, from this root on to the left, that doesn't change because those have positive y values. So let's go ahead and plot that. So that root on up like that. And then, okay, and then the next section, here it has negative y values. We won't worry about that yet. But the next section is after the second root. Second root is here, and then after that, to the right of that, all the y values are positive, so that stays the same. Okay, and now what happens in the middle? Well, all of the y values are reflected over because they're negative. They're negative, so they're reflected over the x-axis to take their positive values, absolute value. Okay, so let's just take the vertex and plot that. So vertex was originally -1, -4. Now it's going to be -1, +4. So it's going to go up here instead. Okay, and then we can connect the vertex to those points like that, drawing nice curves. And there we go. So that is our graph of y equals absolute value of f of x. So now we're pretty comfortable taking the absolute value of functions, and in the future we'll also learn how to take the absolute value of the input of a function. So instead of plotting y equals absolute value of f of x, we'll also learn how to plot y equals f of absolute value of x.